Okay, let's dive into one of the coolest and possibly one of the most useful concepts in geometry. Um, this is something you will see on the SAT and PSAT exams, and let's go to it. This happens to be the presentation of theorems 8.6 and 8.7. Let's start with this. We've got ourselves a right triangle. It happens to be a 45-45 right triangle. But Mr. Peter, you didn't tell us that was 45. Oh, this angle here? Well, of course it's 45 because if that's 90, whoops, if that's 90 and that's 45, there's nothing else for this to be. It's got to be 45. Therefore, what kind of triangle is this? It's an isosceles triangle, yes. So, anytime you have a right triangle with a 45-degree angle, you immediately know you've got yourself an isosceles triangle. So this is special. We refer to it often as a 45-45 triangle. Now, in a 45-45 triangle, let's see if we can figure out what the hypotenuse is in terms of one leg. If this guy is x, think with me now, tough question. If that's x, what's this? X? Yes, it's also x. Because an isosceles triangle, the legs have to be congruent. So now let's use a squared plus b squared equals c squared. But we don't know what the numbers are. That's all right. We're going to go ahead and fill in what we have. X squared plus x squared equals my unknown c squared. I want to find out what c is. What's x squared plus x squared? Oh, it's x to the fourth. No, it is not. That's silly, silly imaginary student. No, x squared plus x squared is not x to the fourth. That's x squared times x squared is x to the fourth. You wouldn't expect x squared plus x squared to be the same thing as x squared times x squared, would you? No, I guess not. All right. So what is one of these x squareds plus another one of those x squareds? Oh, it's 2x squared. Yes, it's 2x squared. Good. That's equal to c squared. Now I'm still trying to solve for c. I want to know what in the world is my hypotenuse. What is c? So I'm going to take the square root of both sides. The square root of c squared is c. Look at that. We have c by itself. Congratulations. What about the other side? We've got the square root of 2x squared. Well, guess what? I know the square root of x squared. The square root of x squared, I'll put that exponent here, it doesn't really matter, but the square root of x squared, the square root and the square undo each other, it's equal to just plain x. So that x can, you know the word, come on, say it. Pa-ching! The x squared pa-chings out, but the 2 can't come out, so we end up with x times the square root of 2. Can I simply erase this and replace that with this? X times the square root of 2. Oh, that is a grand conclusion. Grander, far grander than you might think. We just showed that in an isosceles right triangle, in a 45-45 triangle, if you know the leg, even if you only know one leg, and you need the hypotenuse, we just showed that that hypotenuse has to be equal to x times the square root of 2. Why is that so grand and glorious? Well, what if x happens to be 5? Then that means the hypotenuse must be simply 5 square root of 2. Yes, all you have to do to find the hypotenuse of a 45-45 triangle is take the leg and stick a square root of 2 next to it. Yes, I know that's terribly unmathematical language. Stick a next to it. Yeah, but that's how I think of it. Just take your leg and stick a square root of 2 next to it. You've got the hypotenuse. Well, that seems way too easy. Yes, it is. Way too easy. Hey, what if we wanted to go the other way around? What if we knew what this was, the hypotenuse, 5 square root of 2, but we don't know what the leg is? Can we simply reverse the process? Instead of sticking the square root of 2 next to it, can we just take the square root of 2 away? Yes, we can. So if the hypotenuse happens to be 5 square root of 2, then the leg must be 5. Hey, what's the other leg? Oh, I don't know. Yes, you do. The other leg, it's an isosceles triangle. So if that, oh yeah, 5. Yep, it's going to be 5. All right, let's see some examples of this. Oh, okay, first, before we do the examples, forgot about this. I want to lay this out for you as clearly as I can. By the way, I'm about to show you something that is not laid out for you in the book. And the likelihood that you're going to come back and replay this a dozen times when you're preparing for the test is pretty slim, right? So you need to write this down someplace. Yeah, hit pause, go and get some paper and a pencil or a pen, I don't care. By the way, multicolors would be nice. This diagram works better if you use 2 or 3 different colors, perhaps. But the more you write something down, the better you remember it. It's a known scientific fact. The act of writing it down helps you remember it better. Plus, you've got it in a nice, concise place where you can go back to it without having to go back to the video. And what I'm showing you is not in the book. All right, here it is. You want to title this 45-45 Shortcuts. Draw yourself a right triangle. Try to make it look like it's isosceles. It doesn't have to, but if you can make this side look like it's about the same as that side, then that's good. Then connect the endpoints, and you've got yourself a 45-45 triangle. Label at least one of the angles as being 45 degrees. You don't have to label them both. And label this guy as having a length of x, and the hypotenuse we now know must therefore be x times the square root of 2. I'm going to lay down some rules here. You might wonder why. This is so simple. Why do we need to do this diagram? Because we're going to add something else to it a little bit later here, which will make it potentially more confusing. But if you have these diagrams, it'll be much easier. All right, so the rules. If you have a 45-45 triangle, 45-45 shortcuts. If you have a 45-45 triangle, we now know that if you start with this guy, how do you get to that guy? You simply multiply by square root of 2. So I'm going to put in the words here, multiply by square root of 2. That's all there is to that. But what if I start with this guy and I want to go back to that guy? Well, I reverse the process. How do you reverse multiplication by square root of 2? Yes, divide by square root of 2. So I'm going to put the words divide by square root of 2 down here, if you're going that way. Now, here's the big question, though. Wait, Mr. Peter, I have a question. All right, go ahead. See if your question is the same as my question. Yes, how do we do that? How do you do what? How do we divide by square root of 2? Ah, I'm glad you asked that question. Let's write that question right down here. Oh, let's just call it, but how? We have to divide by square root of 2, but how? Here's the but how answer to how do we divide by square root of 2. There are 2 scenarios. Scenario number 1. If there is a square root of 2 to drop, then guess what? Drop it. That's how you divide by square root of 2. If there's a square root of 2 to drop, then you drop it. We'll see what that means with some examples in a few moments here. Hopefully you'll find it self-explanatory. Scenario number 2. What if there isn't a square root of 2 to drop? Oh, now that's different. If not, If there is no square root of 2 to drop, then what in the world do you do? Well, let's see if we can develop a shortcut rule here. Let's just have an example over here. You may or may not want to copy this example down. Suppose the hypotenuse, instead of being something like 6 square root of 2, suppose it's just plain 6. How do you divide 6 by the square root of 2? Well, would that not be 6 divided by square root of 2? Yes. But, you can't leave a fraction with a radical in the denominator. So we have to fix it. You may remember, and I don't recall if we reviewed this. I think we did review this in a previous video. How do you get a denominator, a radical out of a denominator? How about if we multiply this thing by square root of 2 over square root of 2? That's legal, by the way, because what is square root of 2 divided by square root of 2? I don't know. Sure you do. They taught you back about 2nd grade what a number divided by itself is always equal to. A number divided by itself is always 1. All I'm doing is multiplying by a fancy name for 1. Therefore, it's quite legal. Well, what happens when I do that? Here I get 6 times square root of 2. You know how to multiply fractions. What's the square root of 2 times square root of 2? 2? Yes, 2. But then what's 6 divided by 2? 3. That's right. 3 square root of 2. We're done. Now, starting with this, do you see a clever shortcut to get to this? How about if we just take half of this, take half and stick a square root of 2 next to it? Yes, just take half of this and stick a square root of 2 next to it. It works every time. If, for instance, if this had been an 8, then this would be take half and stick a square root of 2 next to it. Hey, what's this guy? Same thing? Yep, same thing. What if this were a 12? Well, this would be 6 square root of 2. And 6 square root of 2. But what if this were something odd, like maybe an 11? Oh no, what do we do? Well, how do you divide 11 by 2? Watch how gloriously simple this is. Just put a 2 under it. And then don't forget to stick a square root of 2 next to it. There you have it. If the hypotenuse is 11, then the legs must each be 11 halves square root of 2. Yes, I know that's equal to 5.5, but we don't like to mix that notation with this notation. That looks kind of weird. We also don't like 5.5. That's really nasty. We much prefer to write 11 halves square root of 2. When you get to pre-calculus, you'll see the same notation. You'll see it expressed as an improper fraction, 11 halves square root of 2. All right, so back to our rules. If there's a square root of 2 to drop, then just drop it. In other words, if this had been 5 square root of 2, then the leg is just going to be 5. But if there is no square root of 2 to drop, if there is not a square root of 2 to drop, if not, then what do? We divide by 2. You know, that's not easy to say one thing and write another at the same time. Divide by 2 and stick a square root of 2 next to it. If there is no square root of 2 to drop, then you take half and then multiply by square root of 2. Divide by 2 and stick a square root of 2 next to it. Those are your 45-45 rules. Now let's move on to something else. Well, some examples first. Yes, here are the examples. If you see this diagram, you've got a 45, 90 triangle, meaning it's a 45, 45 we call it normally. We know the legs have to be the same, so x is clearly going to be 8. Well, what's the rule say for the leg to the hypotenuse? To go from leg to hypotenuse, to go from leg to hypotenuse, you simply multiply by square root of 2. Stick a square root of 2 next to it. So, yep, if that's 8, then that's 8, and this becomes 8, stick a square root of 2 next to it. Done. This guy, if that's 3 square root of 2, then this is 3 square root of 2. But how do we stick a square root of 2 next to it if it already has a square root of 2? Do it anyway. You get 3 square root of 2 and stick a square root of 2 next to it. But what's the square root of 2 times square root of 2? Is it not just plain 2? So what do we have here? 3 times 2. 6. So x is 3 square root of 2, y is 6. Another example. If that's 5 square root of 3, then this guy must be 5 square root of 3. Here's your right angle. The legs must be congruent. Here's your hypotenuse. What do? You take your 5 square root of 3 and stick a square root of 2 next to it. How do you do that? Oh, very simple. All you have to do is multiply square root of 3 times square root of 2 and get square root of, guess what? 6. Done. Oh, that was easy. Another example here. Why is that 12 down here instead of up there? I don't know. That's kind of weird. Doesn't really matter, but it's a little confusing to me. Okay. So, again, we have ourselves a 45, 45 triangle because there's your right angle. If that's the right angle, that makes these guys the same. So once we found one, we found them both. Well, how do you go from hypotenuse to leg? Oh, let's review. To go from hypotenuse to leg, we do what? We divide by square root of 2. But how? If there's a square root of 2 to drop, then we drop it. Do we have a square root of 2 to drop here? Where are we? No, we don't. If not, then we take half and stick a square root of 2 next to it. So, what happens here? There's no square root of 2 to drop. So we take half and stick a square root of 2 next to it. We take half and stick a square root of 2 next to it. By the way, I've warned you earlier that work must always be shown. But if you know what you're doing on these guys, how much work is there to show? Yeah, none. This one, oh, there's a nice one because the rule here says by the way, I forgot to mention here in the diagram that that's a 45-45 triangle. So I need to label one of these as being a 45. All right, so now we have a legal 45-45 triangle. It's a right triangle. Okay, everything's cool. So hypotenuse to leg, what do? We divide by square root of 2. If there's a square root of 2 to drop, then we drop it. So x and y must both be 4. Mr. Peer, this is too easy. Yes, good. Good, I'm glad you feel that way. This one's a little bit uglier. A little bit, not worth mentioning really. From hypotenuse to legs. Divide by 2 and stick a square root of 2 next to it. Divide by 2 and stick a square root of 2 next to it. Done. Of course, same thing over here. By the way, when you write this, there are 2 different ways you could write this, and there's one way that you dare not write it. You can leave it just like this, or you can put the square root of 2 in the numerator, because really it's 7 halves times square root of 2 over 1. But you dare not allow that square root of 2 to slip into the denominator. That's silly. That's not multiplying by square root of 2, that's dividing by square root of 2. You don't want to do that. So, we take half of the 7, and stick a square root of 2 next to it. Or put the square root of 2 in the numerator. Alright, we now move on to another concept. That was all about section, or theorem 8.6. Now we look at theorem 8.7. This is a 30-60 triangle. A right triangle with angles of 30 degrees and 60 degrees. A 30-60 triangle, we call this. Of course, you know that if someone tells you this is a right angle, and they tell you that's 60, then you automatically know this has to be 30, or the other way around. If you know that's 90 and you know that's 30, then you automatically know this has to be 60. So you don't have to be given all three angles. Alright, now, 30-60 triangle, very interesting. What happens if I take a copy of this triangle, but flipped around the other way, which I happen to have one of right here. Same triangle, just flipped around. In other words, that's 30 degrees, and that's 60, and that's 90. If I put the two triangles together like this, if that's 30, and that's 30, and that's 60, and that's 60, and that's 90, and that's 90, then I have myself what kind of triangle? 60, 60, 60. That's an equiangular triangle. But we saw a long time ago, back in some previous chapter, we saw that equiangular triangles will also be equilateral. This is an equilateral triangle. Well, wait just a moment. If that's x here, then clearly this has to also be x. Which makes this entire side how much? Not x squared. X plus x, 1x plus 1x, 2x. So if this is 2x, and it's an equilateral triangle, if that's 2x, this must be 2x, and this must be 2x. Now watch this magic. Oh, I have to pull that away. I can't erase it. Okay. That was cute. It came right back. All right, here's the point. If you have yourself a 30-60 triangle, and you know the short, and you know the short leg is x, how do you find the hypotenuse? It's just 2x. If you know the short leg, all you have to do is double it to get the hypotenuse. That's so cool. Why? Because a 30-60 triangle is nothing more than half of an equilateral triangle. So of course this must be twice as long as that, because it's just half of an equilateral triangle. Now I need to get rid of some of this stuff here. It's a little messy. Alright, so we now know if this is x, then this is 2x. If this is 5, then this is 10. If that's 7, then this is, get out the calculator, 14. What if this is 20? Then this has to be 10. Alright, now, with that in mind, one moment, making a mess over there. Let me kill this guy off. There. Alright. Let's figure out what this is. Let's call it
It's
A.
a triangle. It's a triangle.
You think it's a triangle. It's far more than just a triangle.
It's a right triangle
True.
as compared to a wrong one?
Wrong. It's far more than just a right triangle, Mr. Leach.
Okay.
It's a 30-60
Ooh.
triangle.
I like that.
That's special.
It is. Thank you.
Thank you. Where were we? We're going to use a squared plus b squared equals c squared. Where in this case, a is just a, but what's b? B b must be x. And c is, c is 2x. And I've got to square the whole thing. A squared plus b squared equals c. C squared. Let's simplify this. What's 2x squared? What's 2x? 2x times 2x. That would be 4x squared. Right? So I'm just going to erase this and call it 4x squared. Now let's subtract x squared from both sides. This is so clever. I love the simplicity of this. I'm going to subtract x squared from both sides. If I subtract x squared here, of course, it's gone. Poof. On this side, what's 4x squared minus 1 of those x squareds? Does that not leave us with just 3x squareds? Mm-hmm. Now we'll take the square root of both sides. A is the square root of 3x squared. But the same trick we saw earlier. I can paching out the x squared. Paching! It turns into an x on the outside with a 3 stuck on the inside. What's our conclusion then? That a must be x square root 3. Oh, wait a minute. I think I see what you're saying. Yes, you do see it. That as long as I know what the short leg is, I can easily find the long leg by just sticking a square root of 3 next to it. Glorious in its simplicity. Or I can find the hypotenuse just by doubling it. Done. Let's summarize. Again, it's time for you to take some notes because I'm going to show you yet again another diagram that is not in the book that could be very helpful to you to remember these properties that will show up on the SAT exam, probably on the PSAT exam, and most definitely they'll show up on the Chapter 8 test. All right, 30. So you want to title this section of your notes 30-60 triangle. Make yourself a right triangle. Try to make this side look shorter than that side. Just make a side, make a right angle, and make this side longer than the first one. Connect your ends. You've got a nice looking 30-60 triangle. Label it. We'll put a 60 down here, or I could have put a 30 up there, or I could do both. Label your short leg as x and your long leg as x times the square root of 3. And then label your hypotenuse as 2 times x. 2x. Now for our arrows. Very similar to what we did back here. Let's throw in some arrows. What's the rule for going from the short leg to the hypotenuse? All we do is double it. All we do is multiply by 2. That's it. Multiply by 2. How do you reverse that? If this were 16, then what's the short leg? Well, half of 16 is 8. So to go from here back to the short leg, you're going to divide by 2. You're going to take half. So that side's real easy. Now this side, in a sense, is just as easy, but there's a little bit of trick to it sometimes. For this side, how do I go from short leg to the long leg? Short leg to long leg, I'm going to multiply by square root of 3. How gloriously simple. And how do I go the other direction? From the long leg, trying to find the short leg. What do? I will reverse this rule. What's the opposite of multiplying by square root of 3? I will divide by square root of 3. Mr. Peter! What? But how? How what? How do you divide by square root of 3? Oh, okay, I'm glad you asked. How do we divide by square root of 3? Let's put the rules right here. But how? All right. I mean, we know how to divide by 2, and we know how to multiply by 2. We know how to multiply by square root of 3. But dividing by square root of 3 may be a little tricky, but not really. So here are the rules. Rule number 1, you might be able to guess what rule number 1 is. The beauty of it is, it's the same as rule number 1 back here, except instead of square root of 2, it's going to be square root of 3. So, rule number 1, if I'm trying to go from long leg to short leg, if I'm trying to divide by square root of 3, how do I do that? If there is a square root of 3 to drop, then what should we do? Well, how about then drop it? So if this side were 8 square root of 3, then the short leg would just be 8. If this were 17 square root of 3, this would just be 17. By the way, if this were 17 square root of 3, then this would just be 17. And this one would be twice 17. This one would be 34, for example. All right, what about rule number 2, though? Running out of room here. Rule number 2. What if there is no square root of 3 to drop? If not what? If not a square root of 3 to drop, then what in the world do you do? Well, guess what? You're going to divide by square root of 3. It says it right here. You're going to divide by square root of 3. But how? Okay, well, we're getting there. Be patient. Suppose we have something like, suppose this guy is 9, and we're supposed to divide by square root of 3. We can't leave it like that. I mean, it's that simple. Whatever's sitting here, you put a square root of 3 under it. That's it. But you can't leave it that way. You have to get that radical out of the denominator. How? Well, we've seen this before. We're going to multiply by a very cleverly chosen name of 1. We're going to multiply by square root of 3 over square root of 3. Pretty cool, huh? Because that's going to give us 9 square root of 3 over, what's square root of 3 times square root of 3? 3. Then 9/3, we need to reduce that. That gives us 3 square root of 3. Do you see a shortcut that'll get you directly from here to here? Oops, not from there. I didn't mean that. We started with 9. A shortcut that'll get you directly from here to here. The shortcut is divide by 3 and stick a square root of 3 next to it. We'll see examples in a moment. The rule says, if there is no square root of 3 to drop, then divide by 3 and stick a square root of 3 next to it. How about an example? Shall I simply do a new example right here? Okay. Suppose this is, I don't know, suppose this is, no, let's make it a nice easy one to work with. Suppose this is 12. Then the hypotenuse, what's the rule? From short leg to hypotenuse, multiply by 2. Hypotenuse, 24. Why? Because this whole thing is nothing more than half of an equilateral triangle. That makes sense. Pretty easy to remember. But then how do you go from short leg to long leg? Stick a square root of 3 next to it. 12 square root of 3. What if we're going the other way? What if we start with this guy and we say it's, let's make it 5 square root of 3. From the long leg to the short leg, what do? We divide by square root of 3. But If there's a square root of 3 to drop, then drop it. So this becomes 5. And if the short leg is 5, the hypotenuse must be, right there. It must be 10. Done. What if there's no square root of 3 to drop? What if we do have a 12 here? To go from long leg to short leg, we always divide by square root of 3. How do we divide by square root of 3? If there's a square root of 3 to drop, then we drop it. Oh, there isn't. So sad. So we could go to rule number 2. If not, then we divide by 3 and stick a square root of 3 next to it. Done. Ha! Yeah, that's all there is to it. Then to get to the hypotenuse, we still just double it. How do you double 4 square root of 3? Yep, 8 square root of 3. 4 of these guys doubled is 8 of those guys, not 8 of somebody else. Don't you dare double that 3. 4 square root of 3's doubled is 8 square root of 3's. And we're done. What if your long leg can't be divided evenly by 3? So what? Suppose this is 11. From long leg to short leg, divide by square root of 3. But how? If there's a square root of 3 to drop, then drop it. If not, then divide by 3. 11 over 3. And stick a square root of 3 next to it. Done. Then how do you double that to get the hypotenuse? Well, how do you double any fraction? Just double the numerator. Just double the numerator. Multiply by 2 over 1. So this becomes 22 thirds square root of 3. Examples. Oh, this was, okay, moving on. Examples, here we go. Short leg 5. Do not think in terms of left, right, up, and down, because in this case I've got the triangle flipped around the other way. So this time, where's the hypotenuse? Here's your hypotenuse. It's the hypotenuse that's twice the shorter leg, because this is half of an equilateral triangle. So if this is 5, x must be 10. Then from short leg to long leg, you're just going to stick the square root of 3 next to it. Done. Let's look at this guy. Well, if that's the 30-degree angle, this must be your short leg, even if my diagram doesn't look like it. But I think my diagram does look like it. Here's your short leg. From short leg to long leg, stick a square root of 3 next to it. X must be 7 square root of 3. Short leg to hypotenuse, double it. 7 doubled, 14. It's over. It's over. Oh, this time we're starting with the hypotenuse. Well, to get from the short leg to the hypotenuse, we would have doubled it. So to go from the hypotenuse back to the short leg, you're just going to take half. And then short leg to long leg, stick a square root of 3 next to it. Done. Look how marvelously simple this is once you remember the rules. You just have to know the rules. Oh, this one's a little bit different. A little bit different. Hypotenuse is 9. From hypotenuse to short leg, we always take half. Like here. Hypotenuse to short leg, we took half. Hypotenuse to short leg, we take half. Well, what's half of 9? 4.5. Yes, but we don't like mixed numbers. We're just going to call it 9 halves. We're not going to call it 4.5. That's ugly. We're going to leave it as 9 halves. We like improper fractions. There's nothing improper about an improper fraction. 9 halves. Then to go from short leg to hypotenuse, just stick square root of 3 next to it. So we have 9/2 square root of 3. Done. Look at this guy. Here, we're given the long leg. How do you go from long leg to short leg? Divide by square root of 3. But how? But how? How do you divide by square root of 3? If there's a square root of 3 to drop, then drop it. If there's a square root of 3 to drop, then drop it. Long leg 4 square root of 3. Short leg must be 4. Hypotenuse, short leg to hypotenuse, just double. We get 8. Nothing to it. By the way, notice how in all of these examples we go through the short leg. I didn't give you a rule to get from the hypotenuse directly to the long leg. Nor did I give you a rule to get from the long leg directly to the hypotenuse. We could have a rule like that, but my humble opinion is, why learn another rule if you can always consider the short leg to be kind of like home base? If I give you the short leg, then finding the hypotenuse and the long leg is easy. If I give you the hypotenuse, take half and get the short leg. Then just multiply by square root of 3. If I give you the long leg, first find the short leg, then double it to get the hypotenuse. Notice I never go that way, I never go that way. Why bother? I consider the short leg to be kind of like home base. Always pass through the short leg. So in this case, I'm going to find x first. I'm going to find the short leg first. If I'm not given the short leg, I always find the short leg first. Long leg is 9. How do I go from long leg to short leg? Divide by square root of 3. How do I remember if I divide or multiply? Well, from long leg to short leg, aren't you going to get smaller? Does it make sense to multiply by something or to divide by something to make it smaller? Yeah, we're going to divide. That's the only thing that makes sense. We're going to divide by square root of 3. But how? Well, if there's a square root of 3 to drop, then there isn't. So we go to rule number 2. If there is no square root of 3 to drop, then we divide by 3 and stick a square root of 3 next to it. Then to get the hypotenuse, we just double that. 3 square root of 3 doubled is 6 square root of 3. Ta-da! Done. This guy. Oh, this one's a little bit uglier, but we saw an example like this. In fact, I may have used the same number before, I don't remember. If the long leg is 11, long leg to short leg, what do? We divide by square root of 3. But how? If there's a square root of 3 to drop, then we drop it. Never mind. If not, we divide by 3 and stick a square root of 3 next to it. Done. Then short leg to hypotenuse, just double that. Yes, this was the same example we saw earlier. How do you double 11 thirds square root of 3? You get 22 thirds square root of 3. And that ends our examples. And I think that ends, that ends everything. Except for one very important detail. Your assignment, which will be due, let's see, today is, to me it's a Tuesday, but for you guys watching this, it should be Wednesday. So this will be due on Friday. We have classes officially on Mondays, Wednesdays, and Fridays. If I give you an assignment on a Wednesday, it's due on a Friday. So due on Friday will be the following. Let's see, page 301. Page 301. And when I say due Friday, I mean due at noon on Friday. 12 o'clock, noon on Friday. All assignments are due at noon. Okay, so we're talking page 301, numbers 1 through 9 all, but those are too easy, I think. Therefore, adding to that, page 302, numbers, and let's just go, in the past I've assigned all, but being nice to you, let's just make it evens. You might want to try some of the odds for yourself, the answers from the back of the book, see if you're going the right direction, see if you're doing things the right way. But I'm not going to officially assign the odds. Let's make it 302 numbers 2 through 18 even. 2 through 18 even. For number 18, you might want to draw your own diagram. Draw your own diagram. Okay, so there you have it. 301, 1 through 9 all, and 302, 2 through 18 even. That is due next time, which is Friday, assuming you're seeing this on a Wednesday. Alright, that is all I have for you. So, unless you want to see one more time, I do have another file here that I forgot to bring up for you. I don't know how long I've gone. I've probably gone over my usual half hour. There's a nice, concise view of the 45-45 shortcuts. A little bit more neatly drawn than they were before, I think. So you might want to pause it there and copy from that screen. And some examples you can try for yourself, which I'm not going to take time to do for you now. And then the 30-60 shortcuts, you might want to pause the video there again and copy this down for your reference and to help embed it in your brain. The more you write, the more you remember. All right, that's that. So, see you next time. Farewell. Stay safe. Wear a mask.